goal is. I'm not going to tell you what today's goal is, but we're going to together make up some rules here. So looking at these first three questions, what is the distance between the smiley face and the star? What is the distance between the star and the flower? What is the distance between the flower and the smiley face? Who thinks they have a good answer for each of those?
Like, you want the actual number?
Yeah, if you can give me a number, that would be great.
Okay. Wait, smiley face.
Smiley face and the star.
5. 5, yeah. Yeah.
So you got 5 there. What about the second question? 5 again, okay. There we go. What about the last 2 points? 10, okay. Does it matter if, I think you guys were counting this way. Does it matter if I count it this way?
No.
No? Okay. The distance wouldn't be negative then?
No.
No matter which way I counted? Okay. What if I did count that way and made it negative? Could I make it, would it be the same number, just opposite sign? Okay. How could I get it to be the same sign every time? If I wanted, since distance we said was always kind of a positive number before, how could I always make it positive?
Count it a certain way.
Count it a certain way, make a rule up for maybe possibly doing to the right always. Or what do you say?
Absolute value.
Okay, or the absolute value. So a general formula here might look like, well, since this is x direction, we could pick 2 x's. What would you say would be a good formula? You said absolute value something. How can you use any 2 of those numbers here? Let's say 4 and -1. How can you get the distance? You told me it was 5 by using this absolute value. Add them together. So 4 plus -1 is what?
So you just subtract because minus a negative number is +1.
Okay, so you're telling me 4 minus -1 would be 5?
Yeah.
Okay, so I don't want to just use 4 and -1 as 2 numbers. I want to use any numbers. So I need a formula just with variables in it. What would that look like? Well, since these are horizontal.
So x1 minus or x2.
Which one?
Minus.
Okay, so there's minus, you're saying is in there. And we'll go on either spot of that minus.
x1 and x2.
Okay. Does it matter which order? No, I'm just gonna say let's put the second one first and x1 later. Okay. So that's the distance in the horizontal, the x direction. Let's look at the next slide here. What if we go up and down?
Y.
Okay, it's the y direction. Alright, we got that. That's good. How about distance from the smiley face to the star? Or the smiley face to the, smiley face to the star.
Would it be like the same kind of concept?
Same kind of concept, okay, just a different direction. So what do we got, 15 you said? Okay, let's do 15 there. What about star to the far?
Yeah.
Okay, so you're still counting. You're still counting the idea, okay? And then that would mean that the star and the smiley, or the flower and the smiley face would be 8. Why? Without even looking at the picture, why would this be 8? Good. Okay. So if I wanted a formula that works all the time for the y direction, what would that look like then?
Absolute value or minus 1.
Yeah. Absolute value of the difference of the y's. Same thing for the x's that we just came up with. Okay. Question being now, is not horizontal, not vertical. Could we just count it?
No. Yeah, you could.
So you're telling me I could count 1, 2, 3, 4, 5, 6 this way?
I thought you could count like going over, like 1, 2, 3, 4, 5, 6. Oh, it is. No, because doesn't it just go over and then up? My turn kind of slow. Yeah, yeah, that's slow.
Okay, so you were saying we can count over and up and then Somebody else was saying slope, so could we count for distance with it being like this?
Yeah, you could. Yeah, that would be the distance.
Okay, let's see what happens. Remember that guy?
No.
That guy was kind of weird. What did I tell you? His name started with P. Pythagoras. Okay. Pythagoras. I think that's how you spell it. What did he give us?
Theorem plus b. I'll make a triangle.
Okay.
Yeah.
So he gave us a squared plus b squared equals c squared, and ab being what? The length of the legs, and c being the upper right triangle, so we need a right angle in there. Can we combine this idea in order to find the slant height, or the slant distance? We just talked about, I think, this distance and this distance. Can we combine it with this idea that Pythagoras gave us?
Yes.
Okay. What would that look like? What would go right here for A?
Our theorem that we just, or formula that we just talked about.
Okay. Which would have been what for us?
Y2 minus Y1.
Okay. And then what would go right there? All right. So we're going to combine these two formulas that we came up with for A and B in order to find C somehow. All right, so let's combine them. Do I know an equation? Well, we just answered that question. Do I know an equation for the horizontal distance? That was the x equation. Do I know one for the vertical? That was the y. And the slant one we said was going to help us with the Pythagoras theorem. So we see here, a squared and b squared become our two formulas that we got. And distance, could I call that something else besides distance squared? Could I call it d squared if I wanted to? Okay. It's a variable, right? What is our goal here, though? Find the distance. What do we have right now if we substitute those things in for A, B, and C? Do we have distance?
Well, we have A and B, and then we can use those to get the distance.
Okay, but do I have a distance formula right here? My question is distance by itself? No. How can I get it by itself?
Get rid of the square.
How do you get rid of square?
Square root it.
Okay, so if I square root that side, I got to square root this side. Okay. If I'm squaring these two numbers here, why did I have absolute value bars in the first place?
To make sure it always comes up positive.
Because it was always needed to be a positive distance. If I'm squaring it, isn't it always going to be positive anyways?
Yep.
So can we change these absolute value bars to something else? We change it to parentheses. So let's do that. If we said, okay, there's our formula up here, we square rooted it and changed them to parentheses, we have a distance formula that works all the time for horizontal, vertical, slanted, or do we? Is this distance formula going to work all the time?
Yeah.
I hope so. There's no numbers in there that would could prove otherwise. Right, so let's see here. Somebody want to volunteer to see if it works?